start by talking about the rectangular coordinate system. This is your typical XY axis coordinate system, split up into 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Right? And you describe locations by where they are with respect to the x-axis and the y-axis. So if I want to know where is that location, well, that is 1, 2, 3 in the x direction and 1 in the y direction, so it has coordinates 3, 3, 1. Okay, so I assume most people in this course would be familiar with the rectangular coordinate system. We're going to look at some relationships between points. So given 2 points, I'm going to call the first point x1 comma y1 and the second point x2 comma y2. Then we can find the midpoint. So this would be, you have a point, you have another point, and you want to find out what point is halfway in between those two. Where is it in the middle? So another way I like to think of this is as the average point. Because if you think about it that way, then you know the formula for finding this. The way you find the average of 2 values is you add them up and you divide by 2. Well, this midpoint is at the average x value. So add the x values and divide by 2. And the average y value. So add the y values and divide by 2. So if you think about this as an average, add them together, divide by 2, and this is a point. Let's make that clear. This is a point, so it has an x-coordinate and a y-coordinate. It's a location. So let's say we had 4, 6, and -3, 1, and I said, okay, where's the midpoint at? Where's the point halfway between those two? So 4, 6 is, roughly about, somewhere up there. -3, 1 is roughly about somewhere there. We're looking for, some within in this area, right? So if we don't get that answer, we know we did it wrong. So you can draw yourself a quick little sketch like I did there and kind of draw it and figure it out. So I'm going to put these numbers in. So the first x value plus the second x value, divide by 2. First y value, second y value, divide by 2. So this is going to give me 4 plus -3 is 1, so 1/2. 6 plus 1 is 7, so 7/2. And if you wanted to, you might, since we're graphing this, it might be easier to write this in decimal form. So 0.5 and 3.5, if that helps. And so, a half and up 3, yeah, that'd probably makes sense with my quick little sketch here. So yeah, think average point. Another relationship we can look at if we're given 2 points is the distance between points. How far are the points away from each other? And sometimes you hear this called the length of the line segment, connecting them. Either way, how far away are they from each other? Now this formula is a little less intuitive, at least initially. You're going to do the distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if I want to find out how far away are 2 points from each other, what I could do is say, well, let's say I'm given 5, 3, and 6, 8. I want to find out how far are these 2 points from each other. I fill them in my formula here. So x2 is 6, x1 is 5 squared, 8 minus 3 squared. I'm going to work these out. So 6 minus 5 is 1, 8 minus 3 is 5, so 1 squared is 1, 5 squared is 25, so this is the square root of 26. Now, this is 2 times 13, so that's not going to break down. Now, in this point in the course, we're not actually going to be breaking these down. So this is either going to come out to be a perfect square, it's going to break it out nicely, or it's going to come to be something like this that doesn't break out. And so that's the exact distance. Now, we can put that in a calculator and find a decimal approximation. Excuse me. But they don't want that. They just want, let's just figure out the exact value at this point. All right, so those are two things we can find. The next thing we're going to look at is plotting points, and so with equations and finding the graph of the equation. So let's talk about a solution point. This is a point, this is an XY pair that satisfies an equation. Okay, so let's say I have 3x minus 2y equals 24. Okay, and I ask, is 4, -6 a solution point? In other words, if I plug in 4 for x and -6 for y, will I get 24? So 3 times 4 minus 2 times -6. Does that give me 24? Well, 3 times 4 is 12. -2 times -6 is positive 12. So the answer is yes, it is. It is a solution point. So on the graph of this equation, it goes through for -6. Now, maybe a better thing to ask is, if x equals, let's say, -6, so x equals -6, what is y? So that's what a lot of times you'll be doing, is trying to figure out, if I have an x value, what's the y value that goes with it? And so you're going to go to your equation, you're going to plug in -6 in for x, and I'm going to solve this. So -18 minus 2y equals 24. Add 18. -2y equals 42. Divide by -2. And you get y equals -21. That means there is a point, -6, comma, -21, that satisfies that equation. This is another point that this graph goes through. And by doing that, you can figure out some points for it, and that will help you draw the picture. So it does kind of help to know what kind of picture you're drawing, to know how many points you need to find. But this is a way you can find it. Now, notice we had 3x minus 2y equals 24, and I had to move a bunch of stuff when I said, okay, x was -6, what was a y? Well, if I wanted to find several points like that, I wouldn't want to do that every single time. So a more convenient way might be to work on getting the y by itself before you start picking values for x. So divide everybody by -2. And we get y equals positive 3/2 x minus 12. And so now, if I wanted to graph this, I could pick some points here. I could say, well, what if x is -4? What if x is -2? What if x is 0? What if x is 2? What if x is 4? You'll notice I'm picking even numbers. The reason why is if I look at the bottom here, of my fraction, that's a 2. I want to pick multiples of that number to plug in so that they will, when I multiply here, they'll cancel out and come out to be something nice I don't have to do that. I can pick any number. It just means your answers might not come out to be something nice and easy to work with. So if I plug -4 in here, -4 times 3/2 is going to be -6 minus 12. So that's going to be a -18. -2 times 3/2 is going to be a -3 minus 12. So that's going to be a -15. I put 0 in there. Well, 0 times anything is 0. Minus 12 is going to be a -12. And then I put 2 in there. That's going to be a +3. Minus 12 is a -9. And I put 4 in there, and that's going to give me a +6 minus 12 is a -6. And there are several points. If I'm going to graph that, here, -4, -2, 2, 4. One thing to keep in mind is you don't actually have to keep your scale the same on both axes, but if you know about graphing certain types of equations, maybe you might want to. In this case, I'm not going to worry about it. So I'm going to count by 3s on the y's and 2s on the x, just based on the numbers I got when I was working this. And so -4, -18, -2, -15, 0, -12, 2, 9, 4, -6. We find this is a line. Okay. So this is, and that may not be surprising to you if you recognize this equation from other courses. But that's an introduction to, well, let me just say before I end here, this process of picking points and plotting it works for more complicated equations. You just have to maybe pick more points to make it work. So that's an introduction to the rectangular coordinate system.